Everyone. Okay, I'm going to switch over and hopefully everything works today. The distant side should be able to see my cover slide there. All right, so just FYI, maybe this is obvious, maybe it isn't, but I don't want to make an assumption, so I'm going to make it very crystal clear. In the fall, we talk about what is normal within each of the body systems. And we also talk about a lot of the professional content that is foundational to what we do. Communication, teaching, legal, ethical issues, etc. But in the spring, we focus more on common conditions, common medical problems that now encompass those nursing problems that you learned about in the fall. So, with that being said, as we look at these conditions, these three that are listed on your screen there, for the next few days, recognize that everything that I shared with you in the fall, in the respiratory lecture, now becomes relevant. What I mean is you're going to identify which of those three nursing problems are most prevalent in each of these conditions. And the interventions we talked about in the fall are now relevant to these conditions. Now, these are by no means all the possible respiratory problems your patient can have. Just looking through those chapters that I pulled pages out of in Biggie, you see that there are multiple other common conditions. We have simply pulled out the ones that are most prevalent, most relevant to the majority of the people that you will be taking care of. And most likely, the ones that you will see tested on NCLEX. Will you see test questions over cystic fibrosis? Probably, but that's most likely going to be covered in maternal child, because that's when we see it show up the first. And so there'll be other things that will add to this list besides these three before you graduate, but this is where we start this semester. So let's begin, and let's go back and just very quickly make sure that before we talk about the problems, the medical problems, we need to just be reminded of how things work normally. So I'm going to very quickly go through these. When we're talking about these three problems, we're really not talking about the upper airway problems, we're talking about the lower airways. And remember, the lower airways involve the trachea, the right and left mainstream bronchi, the smaller bronchioles, and eventually the alveoli themselves. So all three of these conditions we're looking at deals with a lower airway problem. The second part of the anatomy that's become significant is the pleura. Remember, there are two layers of tissue. We call it the visceral and parietal. Visceral pleura is what attaches to the surface of the lung itself, and the parietal is what attaches to the inside of the chest or the thoracic cavity. In between those two layers, there is what we call pleural fluid. It's only a few mils of fluid that helps to lubricate when that chest is expanding and deflating, if you will. So during inspiration and expiration, it functions like motor oil, functions as a lubricant. In your airway, and in our client's airway, there are goblet cells and submucosal glands. They are found primarily in the lower airways, and they provide a mucus layer to protect our airway from invading organisms. So they're not found in the alveoli. So in effect, they function like a glue trap, if you will, to anything you might inhale. So whether that's an allergen, or whether that's a virus or bacteria, hopefully it will get caught in the mucus, and instead of making it down into the alveoli where it could grow and invite its friends. The diaphragm and the external intercostal muscles is what helps us to change the size of our thoracic cavity, allowing us to inspire and expire. The respiratory centers in the medulla, that part of our brainstem, is what is in control of our respiratory function. And then there are chemoreceptors in our carotid arteries, in our aortic notch, as well as the brainstem itself, that detect various changes in the carbon dioxide and the oxygen levels in your bloodstream. So let's put that all together and look at some key points of physiology. Remember, we're going to talk about pathophysiology mostly on Thursday. I don't think we'll quite get there today. We might get the foundation started, but we won't get very far at all. Remember, patho is disease, meaning disease physiology is pathophysiology. So we need to know what normal is so we can recognize abnormal. First thing is remember that the primary control that drives your respiratory effort or your clients is that respiratory center that's in the medulla. It recognizes a change in the carbon dioxide levels in the bloodstream. Primarily, we're talking about in the arterial side of the bloodstream. That's why it's in the carotid arteries and the aortic notch, because that's where blood travels first when it's thrust out of the left side of the heart. Those chemoreceptors measure, if you will, they detect if that carbon dioxide level is outside of what the body desires. If it is, it causes the body to breathe faster and deeper in order to exhale more carbon dioxide and create that balance or that homeostasis we talked about in the fall. But recognize that that's not the only way we control our respiratory effort. That surface part of your brain, we refer to as the cortex, has the capacity to produce voluntary control. That's why you can hold your breath when you want your way and your husband or wife, boyfriend or girlfriend won't buy you that Valentine's present you've asked for. Oh, I'm sorry. I did not mean to. If I offended anybody in that matter, I honestly apologize, all right? Because it just slipped out. I will do my best to try not to interject those things. I truly apologize. If that's what was offensive, I will try to change that. All right, so cortex can produce voluntary control. So holding your breath, being able to control it while you're swimming, those are examples of how your brain can override your respiratory center. So what are the purposes of the respiratory system? So let's start with tongue wall. Fill in that first blank for us. What does the respiratory system convey to the alveoli? What's its primary component?
Oxygen.
That's correct. Conveys oxygen to the alveoli. Enid, what do we exhale to the atmosphere?
CO2.
Carbon dioxide. And then the third purpose is our respiratory system, through the use of that mucosal membrane, as well as our sinus passages, filters and humidifies the air. So it needs to be 100% saturated in order for the gas exchange to occur most effectively. So that's the purposes of your sinuses and that mucus that lines your airway. That mucus traps the particles, and then the cilia, those little hairs that line that airway, carry it, kind of like the minions when they hand something from one minion to the next. It's that same process, causing whatever is trapped in the mucus to eventually either be coughed out or swallowed. And then our respiratory system also assists in acid-base balance. And as I mentioned in the fall, you'll talk in more detail about that in adult too. But recognize that our body requires a certain pH for all the body's systems to function safely and to function well. Oxygen and carbon dioxide make their switch in only one part of the respiratory system, and that is in the alveoli themselves. And they must be able to cross the membrane that separates the alveoli from the capillaries. And we call that the alveolar capillary membrane. And remember we said in the fall that there are two components of cellular oxygenation. You have to have a working ventilation system, which is our respiratory system, and you have to have a functional perfusion process, and that is our cardiac system. During these next 3 days, we're focusing primarily on the ventilation side again. In a few weeks, we'll talk more about the perfusion again. So let's talk now about the process of ventilation. This may seem very redundant, but the reason we're covering all of this is we're going to see how most of the things we've already mentioned are disrupted by one or more of these three diseases we're looking at. So the very first part of taking a breath is when your diaphragm and those external intercostal muscles contract, and it is an active, intentional process. When they contract, they enlarge the thoracic cavity, creating more space in that pleural cavity, which allows atmospheric air to rush into the lungs and into the alveoli. The muscles relax, And then it is the elastic recoil of the alveoli themselves that forces air out of the lungs during expiration. And that is by design supposed to be a passive process. We're going to see with two of these diseases where it's not. So if that's the way it's supposed to work, then here are 4 key elements that must be in place for it to work the way it's supposed to. The first one is airway resistance. In other words, it's how much resistance to airflow is being generated in that airway. Okay, so if you remember, we said that one of the primary nursing problems that we talked about last fall was compromised airway. Well, airway resistance is influenced both by the diameter of the airway as well as the volume of mucus that is lining the airway at any given moment in time. What I mean by that is the smaller the diameter, the greater the resistance to airflow, both inside, going in for inspiration or out for expiration. The greater the volume of mucus, again, it narrows the lumen of that airway and affects how easy it is for that person to ventilate. Compliance. Compliance simply means how easy it is for the lungs to expand and to take in that breath. Okay? So there are diseases that disrupt compliance for the individual. And as a result, they're not able to ventilate effectively. In fact, simple process of aging changes our compliance in the negative as well. Okay? So as a person gets older, their compliance decreases just from getting older. Surface tension. We talked about surface tension and we talked about surfactant last fall. Remember, surfactant is that chemical that is released in the alveoli that helps keep the alveoli open when we exhale. Remember, we said that if a person doesn't have adequate surfactant production, when that person exhales, the sides of the alveoli might choose to stick to each other, and then the lungs collapse, okay? Making the alveoli very difficult to reinflate. So think we're at Stillwater. Stillwater, name one people group where this could be an issue with their respiratory distress. When would be a time where what's a people group that might not have adequate surfactant production? Infants, especially premature ones. Okay, very good. And remember, it's during those deep breaths or those sighs that surfactant is released. That's why the natural process is that a healthy adult sighs several times a minute. And then muscular effort. So the pleural cavity must increase in size for inspiration to occur. And so that muscle effort can be disrupted not just by a respiratory problem, but a neurological problem as well. So a spinal cord injury or a multiple sclerosis individual or some other neurological process can disrupt the ability for a person to take it in their breath or to take in an adequate size of breath. Okay, I'm going to switch to the document camera for just a moment, and I'm going to remind you of something else that we talked about before we begin looking at these diseases. Okay, so let's see if we lose our picture when I play with the buttons. Nope, so far so good. All right, so during the fall, I think I introduced you to this idea that we call the respiratory continuum. And so if you can imagine something that goes infinitely in both directions, at some point in this continuum, we would describe healthy functioning, and it would look just like the things we just described. The person would have effective ventilation, they would have appropriate airway resistance to allow adequate breath in and out. They would have enough compliance, not just to take breath in, but to be able to exhale through elastic recoil. They would have plenty of surfactant, and their muscle effort would be adequate to meet their oxygen and gas exchange needs. So the healthy individual we now understand. But remember, we said that there are many things we encounter from day to day that can challenge our respiratory system. So let's go to Tonkwall. Talk to me about some things that changed a person's respiratory function temporarily.
Exercise.
Exercise is an excellent example. When we generate more carbon dioxide and we need more oxygen to utilize our muscles effectively during a rigorous aerobic activity, then our respiratory system is challenged to meet that need. And if we have a healthy system, we meet that need and we restore eventually that healthy function again. Okay? Name something else, Tonkwall.
Occupation,
Say it loud for me.
like occupation.
Can you think of an example of one that might?
Thus,
A dust producing one, is that what you said?
yeah.
Yes, that would be a good example. Again, we're talking about things that, in Oklahoma, that doesn't even have to be an occupation. We can go outside in the spring and there's plenty of things blowing in the air that challenges our respiratory system. Challenges our respiratory system to catch it, to expel it, and not to respond to it in an extreme fashion. Okay? Name me one more. Can you think of one more where our respiratory system might be challenged? I didn't catch it. Try again.
Is smoking one?
Smoking can kind of fit on the challenge and it kind of fits on the insult because we're going to deal with that in more
Elevation,
detail.
altitude.
A single cigarette would qualify as a challenge because you're inhaling a concentrated source of particles as well as a chemical that challenges your respiratory system to recover from that. So it does fit as far as a single moment in time. But another one I'm thinking of is what happens when we are afraid or we're anxious. What does our respiratory system do then? Our adrenaline causes us to breathe a little faster to meet whatever the challenge is. Remember that whole fight or flight thing. Okay, so whatever that perceived threat is sets off a cascade of response that our respiratory system responds to and can easily recover from if it is healthy. Okay? All right, so Amy, let's go to the next one on that list. What would be some examples? We've already mentioned one of them, but what would be an example of something that would insult the respiratory system? Chronic allergies, very good. And we're going to look at that in the context of our asthma patient that we're going to talk about on Thursday. We're going to start maybe in a few moments, but we're going to definitely talk about it on Thursday. Okay? Something else.
Maybe elevation, like pressure.
Okay, so elevation typically does not injure our lungs, so it probably would fall more under challenge because the different levels of gravity and the amount of oxygen in that altitude changes. So somebody has to breathe faster and deeper at a higher altitude if they're accustomed to living down at sea level or down towards sea level. Okay, so I think that would go more under challenge than insult. Insult would be when that pressure causes injury to the tissue, and we call that altitude sickness. Okay, so it kind of fits under both. Good idea. Somebody else? Oh, hold on. We still want Enid to be able to answer this. You guys are going to get your question, okay?
Any other thoughts? Certain medication? Some type of medication?
Yes, there are definitely medications that can insult our respiratory effort. What would be a drug class that we talked about that if we administered, it might affect their respiratory effort?
Opiates?
An opioid, yeah, or a narcotic. Respiratory depression is part of that consequence if they get more than the respiratory center can handle. Okay? Something else that I want to add to that list is bacteria, viruses, or any other form of pathogen that we might inhale. So like the coronavirus that's going around across the world right now. Okay, so those are examples of insults, meaning they're going to injure the tissue, and if the body can recover, it will hopefully move back towards that healthy part of the continuum. Now, Stillwater, can you tell me distress? How do we reach distress? Oh, hold up, I forgot to turn my, go ahead.
Just double checking, you wanna know what the symptoms of the distress would be or what would cause
What could lead to distress?
pneumonia?
Okay, so pneumonia would function as an insult, but when would it become distress?
Decreased.
I'm gonna give all three of you a chance to say, go ahead.
Say, the decreased, yeah.
Well, see, put me on the spot now, I can't
I'm
say
sorry.
Yes. Yes.
Yeah, she was about to say gas exchange, okay, so when the pneumonia, creates an inability for the body to compensate and still generate adequate gases, that would be an example where it can lead to distress, right? We'll just go here, I said there, you had to say something? You didn't say
Well, I
anything?
think from pneumonia is chronic.
Well, we can have prolonged pneumonia, but one of the things that we're gonna talk about on Thursday is pneumonia is always an acute issue. It's not really a chronic. It can be sustained for several weeks, especially in the elderly or those who are compromised, but it is referred to as the upper team as an acute problem, okay? Somebody else?
Blocked airway.
Ooh, a blocked airway would be a great example. So the insult becomes distress if the person cannot clear the airway. Excellent. What else? You think of another one?
Impaired your breathing.
So anything that would impair your breathing where you could not recover without outside help. Okay? All right. So I want you to turn to page 568. And there's a chart, a little one of those little pinkish red boxes. I want you to look at because it's being used for something else by the writer of the book. But what I want you to see is these are the classic signs and symptoms of respiratory distress. Okay, so look at chart 30-5 on 568, the last bullet point, where it says, seek immediate emergency care if you experience any of these. So all of those would be some examples of how you, as a nurse, would recognize this person is moving the wrong direction on that respiratory continuum. They're moving toward respiratory distress, and if I don't intervene, they will move toward respiratory failure.
Can you fix it, Mike?
Anybody on any of the three campuses, what does respiratory failure represent?
They said death.
Well, that would be respiratory arrest. So this is the point on the continuum. See, I didn't actually put respiratory arrest on there.
I don't like this is.
That's off the paper, right? Because they no longer in our world. That's other. But respiratory failure is right, can lead to respiratory arrest.
Another person said atelectasis.
Atelectasis can be a component of it, absolutely.
What you said?
Go back and look at our purposes of the respiratory system we just talked about.
Can you fix
When your respiratory system cannot meet those purposes, then you're in respiratory failure. Most specifically, when they cannot maintain life-sustaining gas exchange or life-sustaining acid-base balance. Those are the two critical components. So you're going to talk in greater detail about respiratory failure in adult too when you learn about acid-base balance and some of those ICU emergent conditions. What I want you to see today, and I'm going to let you go here very shortly, what I want you to see is a person can begin anywhere on this continuum. If they move this direction, you're happy, and they don't. If they move that direction, then it's not so pretty. Okay? So when a person has an acute problem, they may have started here, or they may already have started here because they have a chronic condition that the acute problem exacerbated. So example being that asthma patient that we mentioned, they have an ongoing challenge to the respiratory system, and then they have an infection that occurs, and they very quickly move into distress. Because they started here, it takes less time for them to get here than if the person who started here and had a respiratory infection. It took longer for them to digress to distress. Why is that significant? We're going to look at that, more on Thursday and next Tuesday. We're gonna look at how COPD, we're gonna look at asthma, emphysema, chronic bronchitis, and how those people don't start off here, they're already compromised to begin with, and it doesn't take very much to swing in the wrong direction on a continuum. Okay, so then the last 3 minutes, I'm trying to page 131, gonna look at those last 3 slides if we can get through them. If you can, for the most part. So COPD is not a singular disorder. It is a group of disorders that affect airflow in and out of the respiratory tract.
Mr. Baird, we really can't hear you. I think a student mic could be on maybe.
Oh, yes, you are so right. Sometimes when I let the students answer, I forget to turn the mic back on.
I do the same all the time.
Yeah, it's so easy. Okay, so COPD stands for chronic obstructive pulmonary disease, and I've listed 3 conditions that we're going to look at specifically on Thursday. And what we're going to do is we're going to break those down because they all have the same end result. They all interfere with our ability to ventilate or the client's ability to ventilate, but they do it differently. So the pathophysiology is different. Risk factors are, some of them are same and some are different, but we're going to break all those individual things down. But recognize that these diseases can occur individually or they can coexist. So a client who has asthma can very easily progress to bronchitis and live with it for the rest of their life. That next slide, epidemiology, remember that's the study of disease and its causes, and etiology is what are those causes. So these are just some FYI so that you know how serious are these respiratory conditions to begin with. Well, according to the current text, about 34 million American adults live with it. About 24 million of them live with asthma, and about 15.8 live with emphysema and chronic bronchitis. COPD is the 4th leading cause of death in the United States. It's estimated that $30 billion at least per year results as a result of these people in the healthcare system. There are some specific causes that we link to things, but there's some things that are still not yet fully understood, so we're still learning. And that's where I'm going to stop. I'm going to leave that 3rd slide off because we're going to look at that in more detail on Thursday after you've had some rest and recoup time. Are there any questions though before we dismiss? And I mean that sincerely. I truly want to answer questions if there's something that's clarified. If you think of it later, remember you have the discussion board. And I'll see you on Thursday.